Hello everyone, welcome back. Let's continue the parallel and the sequential stream example. Okay, so this is the previous example which we discussed already. But as I said in the beginning, there is a way we can identify how many processors are running in my machine. We can do that. We can check that. So how we can do that? You can print the data. So runtime dot get runtime dot available processors, which will give you the available processor in your machine. Just run it again, and there you can see 2. This is the count of the processor. That is the reason in my parallel, the parallel run, we can see two different threads. First one is main, another one is the fork chain pool. Okay. Okay, let me create another simple example to show how exactly difference between, like, let's have a sequential and the timing difference between the sequential and the parallel. I'm going to create another class and can have trillion new class file. I'm going to name sequential parallel example. Maybe I can keep it as example 1. Okay, so I'm going to have a main method also. Just click finish. Okay, my class is ready now. Okay, so what I'm going to create two methods. Okay, which will give us the sum of 0 to 100 or 0 to whatever number we want. Okay, so let me create two methods. Static, which will run int sum method using sequential. So return. So I need to return a sum of 0 to 1000 or 10,000. Okay, so I need to have a in stream. So in stream dot, I'm gonna use the range closed. The first one is 0. So the n number is going to be around 1000 or 10,000. Okay, so the method which you're going to use is the factory method is sum. Okay, so let me run this method and see how it is going to return the data. I'm going to print the data here. Okay, so sum from sequential manner. I'm going to call the method and I'm going to print it. Okay, so this is the sum of this particular range close 0 to 10,000. Okay, so I'm going to create another method which will do the same operation, but that is going to work as a parallel manner. So I'm gonna change the name to parallel, and before summing the data I'm going to use the parallel stream and then summing it. Okay, so both method which will return the same data, same output. Okay, let's run it again. See, both the end result is the same. So what is the difference? Okay, so when we are working with a multiple number of threads, so how it is going to be identify which method or which stream is going to be a faster. Okay, let me create an interface method to run the same method multiple times, and we'll see which method is performing faster. Okay, so here I'm going to create another method called static children long and check performance. So this method is going to be accept a supplier which will return an integer, and it's nothing but the sum. Then int how many times I'm going to execute the method. Okay, so but another thing is we need to calculate the timing, the start and the end time, right? So I need to have another variable here to store the start time. So using system dot our current time in milliseconds, which will help us to identify when the process has been started. I'm going to create another parameter to identify the end also. Okay, and return end minus start. Okay, so here in between what we are going to do. Okay, I'm going to create a for loop which is int I is equal to 0 and I less than or equal to the number of execution times. Okay, and then I'm going to increment I is equal to 0. Okay, so now what I'm going to do is I'm going to call the method. So I have a supplier method which is nothing but sum, or else we can sum dot get. Okay, so which will run the method. So here the sum dot get method which will run the method this many number of times. Okay, so here I'm going to make a small change in my main. I'm going to comment out these two. Let me copy this, print the data. But here what I'm going to do is I'm going to call the check performance method which will accept a supplier. So how we can pass that, because supplier some method using segment or a sequential flow and a parallel flow. So I can use a method reference like sequential parallel example get, sorry, some method using sequential flow and how many number of times I want to execute them. I just want to execute them around 25 times. Okay, I'm gonna do the same thing for parallel also. But here instead of sequential method, I'm going to call the parallel method. So the both the method I'm going to call 25 times and I'm going to verify which method is running faster, whether it is a sequential stream or is a parallel stream. Okay, let me run this. Okay, the sum from sequence method took 8 seconds and the parallel it took 35, which is not exactly right. Let's see. I ran it again, but again it's sequential take 8 minutes 8 seconds and parallel took 7 seconds, which is not quite convincing. So what I'm going to do is I'm going to increment the range of data. I'm just using 0 to 10,000. Let me make it as 1 lakh. When we have a huge number, we can identify the exact difference. So I'm going to run it again. Have you seen the difference here? The sequence which took 514 and the parallel is 242. Okay, that's a huge difference. Okay, let's run it again. Let's see the impact. Now it is also nearby, but still parallel beaten the sequential flow. Let's run it again. Again, the parallel flow got the winner. Let's run it again. See, when you have a huge amount of data and a huge amount of data needs to be processed, then we will get to know which method is going to be useful. Okay, in this kind of straightforward logic, whether you don't have to do any internal modification, like if you are executing hundreds of records, that is okay, but while executing it you are making some operations or you're performing some object modifications. Those kind of scenarios, if you go for parallel, then we will end up with an issue. Okay, but for straight kind of iteration, it's always good to go with the parallel, but it's always advisable before you decide which stream you're going to use, just run it multiple times and see which one is giving the better performance. Okay, thank you.